Good day, everyone. I am John Lloyd A. Maghina, your science mentor for today. Are you all ready to learn more about science? Today, we will be tackling about standardization, including all necessary terms under this process. Good. To formally start our lesson, let us first identify our learning objectives. First, at the end of this video lecture, students must be able to know the process of standardization. Second, they must learn the importance of standardizing a reagent. Lastly, they must be able to determine other necessary terms under this standardization process. Let us first identify the reason why do we need to standardize a solution. When a solution is made, there are often mitigating factors that may alter the expected concentration for that solution. Therefore, a mass sample that will be used in a solution may be mostly base, but it may also be partly water. This causes misleading amount of results, though usually the concentration of the solution isn't off by that much. To deal with this, we standardize the solution. What do we mean by standardizing the solution? Standardization is the process of determining the exact concentration or molarity of a specific solution. We determine the concentration of the base more accurately by performing a careful titration. In a titration, a precise volume of one substance is reacted with a known amount of another substance. Titration is one of the typical analytical procedure often used in standardization. It is essential process in chemistry as it gives transparent and reliable results. The results of standardization are of course accurate and correct. Before we expand into the detailed procedure or process of standardization, let us first identify and define the following terms. Titration. The process is usually carried out by gradually adding a standard solution of a known concentration of titrating agent or titrate from a burette. This burette is essentially a long, graduated measuring tube with a stopcock and a delivery tube at its lower end. The addition is stopped when the equivalence point is reached. Next is molarity or concentration. Molar concentration, also known as molarity, is a measure of the concentration of a chemical species in a particular solute in a solution, in terms of the amount of substance per unit volume of solution. Next is the equivalence point. The equivalence point or stoichiometric point is the point in a chemical reaction when there is exactly enough acid and base to neutralize the solution. In a titration, it is where the moles of the titrant equal the moles of solution of a known concentration. A primary standard. A primary standard is a very pure reagent that represents the number of moles the substance contains and is easily weighed. A reagent is a chemical used to cause a chemical reaction with another substance. Often, reagents are used to test for the presence or quantity of specific chemicals in a solution. Indicator. An indicator is a substance that changes its color in an acidic and basic medium. An indicator shows one color in an acidic medium and different colors in a basic medium. Lastly, endpoint. It is the point at which the reaction is complete. Now let's move into the actual process of standardization using titration as sample. The titration itself is conducted with a volumetric burette. The burette is a cylindrical tube with a volumetric scale, the scale being 0.1 ml. As a rule, the raw sample cannot be analyzed directly, but has to be diluted before titration. An accurate volume of the original sample is taken with a volumetric pipette, brought into a volumetric flask and diluted with water. All this sounds simple, but The need for accuracy requires equipment to be prepared thoroughly before starting with the pipette. It has to be cleaned. Flushing with water is a logical step to start with, but heating water will definitely disturb the concentration of the original samples. So, deterring water has to be removed prior to filling with sample. Therefore, standard procedure needs flushing treatments with the water and with the sample. Also, the volumetric flask has to be prepared by flushing. It's important to realize here that the volumetric flask will be used to add an accurate amount of solvent. Flushing should be conducted with the ionized water only. Now, the pivot has to be filled with sample. We filled a pipette using a balloon to some centimeters above the mark. We dry the cell outside of the filter paper. Then in order to get an accurate amount of the sample, we'll let the surplus flow back into the beaker at an angle of 45 degrees. We empty the pipette gently into the volumetric flask again at an angle of 45 degrees and wait for about 10 seconds after finishing. Finally, the sample in a volumetric flask has to be diluted with a dash of deionized water. We carefully add the final drops until the lowest point of the meniscus reaches the mark. Try the inside of the top of the volumetric flask with filter paper and next swivel gently at least 10 times to homogenize the sample. Now, the sample is ready for analysis, but the burette has to be prepared again with the flushing procedure. The burette can now be filled with substance. Allow a bit of space to escape in order to avoid air bubbles in the top. We will then use a volumetric pipette to install an accurate amount of diluted sample here. We will only show you the last flushing with the pipette with diluted sample in total. We flush the pipette 3 times with deionized water and 3 times with diluted sample. Finally, we had a few drops of indicator in a solution, in this case, phenolphthalein. Now, we write down the initial volume of treatment and start titrating. A mechanical stir can be used or we have to swirl gently. We have to proceed until a drastic change of color is observed. The change has to be stable for at least 10 seconds. Note down the final volume of the treatment and repeat the titration 2 more times. The difference between the three values is not allowed to exceed 0.1 millimeters. Now that you have learned the process of standardization, do you have any questions? Clarifications? If none, then let's call it a day. Have a good day and goodbye.